So the rest of excuse me, chapter 5 is about how we know that triangles are congruent. And so there are 5 different ways. And so what this stands for, SAS, is side, angle, side. So there's a theorem. What's the number? 5.5. And it's the SAS theorem, SAS congruence theorem. But it says if two sides and the included angle in one triangle are congruent to two sides and the included angle in another triangle, then the triangles are congruent. Okay, so included angle. I think we know what two sides means, but what does included angle mean? It's essentially the angle that's between the two sides. So if it was, if we had ABC, DEF. So if I had labeled those two sides, then angle A is the one that's between them. So the included angle, like the way that I think it's easiest to think of it, where the two sides meet, that angle. So over here, it would look like that, like if they're flipped over. Okay, so yesterday we talked about congruent polygons, and we said that if, in order for polygons to be congruent, that all the sides had to be congruent and all the angles had to be congruent. Well, specifically with triangles, if you know that two sides and the angle that's between them, or included angle, you don't need to know the other angles. That you know they're congruent, therefore all the other angles and sides are the same, but you don't have to show that. Okay, so again, like for my thing, like included angle is the angle where the sides meet. So on the first triangle, AB and AC, they meet at A. DF and DE. You could also look at it like this. So like on the first one, we're told that AB, or AB is labeled, and so is AC. And on the second one, we have DF is labeled and DE is labeled. And so if you notice, there's an A, there's an A, there's a D, there's a D. The letter that they share will be the included angle. So your first few problems are just going to be, is name the included angle between the pair of sides. And then there's a picture. Okay, so a few different ways to look at it, but all right. Okay, then you're going to have a few problems that'll say decide whether there is enough information given to prove the triangles are congruent using side, angle, side. So we're going to come back to a property that we talked about a long time ago that I said is going to come back and it's going to be prevalent in chapter 5, and so here we are. So is triangle ABD congruent to triangle CBD? So if it was labeled, let's say like that, so it's telling me that AB is congruent to BC, and then it's telling me that the little angles at the top, angle ABD and angle CBD, are congruent. So right now, I know that AB is congruent to BC, and I know that angle ABD is congruent to angle CBD. So here's like our side, and here's an angle, and then I need another side, but it has to be this one in the middle. Okay, it has to be BD. Okay, and so here's this idea is going to come up a lot. So if I separate the two triangles out, and I draw them as two separate triangles. So in the picture, those are congruent, and those are congruent. And so do we see that, like, we have this line BD right here, and it's the same line. They have to be the same. It's the same line, BD. Okay? And so while this question, is there enough information to prove that they are congruent, doesn't necessarily make you do this, but it will in a minute. So I know that BD is congruent to BD because it's the same line. It's the same like side. On the left triangle, if from B to D is 10, well then on the right triangle from B to D has to be 10. It's not different length with the same letters. Okay? So I would have enough information here, even though it's not labeled or given to me, I can conclude that BD is the same or is congruent because it's the same line. Okay, and this is going to be used a lot. That's the reflexive property that we talked about way back in chapter 2. Okay, so that reflexive property is going to come up quite a bit in this chapter. And a lot of the times in this picture right here where you have two triangles that are connected. Okay, so on the section of problems, there's 6 of them that it says, is there enough information? You are allowed to make conclusions by looking at the picture. So in this picture, there's only a side on either one and an angle on either one, but I can conclude, well, BD is the same line, so it has to be congruent. and then what you end up with is a side angle side situation. Okay, so you are allowed to make conclusions. You just need to make sure that when you label, like when everything's labeled, that it goes in order in the triangles for the SAS. So if you notice, like, here's a side, here's an angle, here's a side. I didn't like go side, angle, and then the side was way down here at the bottom. It was like this side, then the next angle, then the next side. It goes in order, it doesn't skip. So this one is side, angle, side. Okay? So just to label something like differently, if you had like these two triangles and it labeled like those angles are right angles, so I know those are congruent, and then it labeled it like this. Is this side, angle, side? No, because the angle isn't included. The angle's not between the two sides that are marked congruent. It's separate. Okay? So you might have an angle and two sides labeled congruent, but in order for this to be side, angle, side, the angles at the top would have to be marked congruent for it to be side, angle, side, or this bottom side would have to be congruent instead of the diagonal or the hypotenuse side. Okay, so don't just look at, okay, two sides and an angle, I'm good. It has to go in order. A side, then the next angle, then the side, or it's the angle where the two sides meet. Okay, so be careful of that. Before, where BD is in the middle and it's shared in both triangles. All right, now everybody's favorite is back. We got to do proofs. Okay, so these proofs, in my opinion, are much easier than the proofs that we did back in chapter 2. Okay, so here's kind of a guideline that we did talk about in chapter 2, but we're going to write the given information down. We are going to make conclusions from the given information. We are going to, God, how do I word this? We are going to use the picture to say something is congruent. And then once you've done that, you should be at the part where, like, you should be done. If you do steps 1, 2, and 3 for today, since we're learning about side, angle, side, you should have, within the steps before that, have said that two sides and an included angle are congruent based on what you've been told from the given and what conclusion you can make. Okay, so let's look at one. We can pretend that that line actually hit the corner up there. So given BC is congruent to DA and BC is parallel to AD. Prove triangle ABC is congruent to triangle CDA. So the top triangle and the bottom triangle. Okay, so step one, write the given. So BC is congruent to DA and BC is parallel to AD, and the reason is given. So whenever, like, I'm going to label like stuff also. So BC and DA are congruent. Okay, and then it also tells me that those same lines are parallel. Okay, so right now I have a side that's congruent. I also kind of like to label those a little bit like I did. Okay, step two, make conclusions from the given. Well, BC is congruent to DA. When something's congruent, there's no conclusion to be made. We have the information because the goal is to say that for today, two sides and an angle that's included are congruent. So I need to say two sides and an angle are congruent. I have the side BC and DA already congruent. So BC is parallel to AD. I need to make a conclusion with that information. Okay, and so here's kind of, let's come down here to the bottom left-hand corner. When you see parallel in this chapter, you want to think that alternate interior angles are congruent. A huge percentage of the time, when you see something's parallel, in that problem, you are going to say this angle and this angle are congruent, and the reason is alternate interior angles. Okay? That's a huge percentage of the time. It can also be helpful when I'm looking at this, it can be a little confusing just as a visual. So like the picture. So if I draw my two lines that are parallel, and I kind of create, here's my two triangles. I'm just not going to draw the sides. You know, this one's parallel and this one's parallel. So here are my alternate interior angles. Okay. Technically there are other like angles, but they're not congruent. Okay, so what about this one underneath, like the C? Well, that doesn't involve one of the parallel lines. Like CD isn't parallel and BA is not parallel. So I have to have the parallel lines. And then if I were to draw, take out this line in the middle, and I put like this one in, well, those are consecutive interior angles. They're not congruent. Like, so it messes things up. So I want to look for kind of also lines that kind of work with my triangles. Okay, so because they're parallel, I can say that angle BCA, which is that one up at the top, is congruent to angle DAC, which is that one down at the bottom, because alternate interior angles are congruent. Okay, so in my picture, it's this one and this one, which is where the X's are, this other part. Okay, so now I have an angle is congruent. Okay, step 3, use the picture to say something is congruent. A huge percentage of the time for this third thing, we're going to use the reflexive property or we're going to use vertical angles. Those are the two most common ideas that you can see in one of these problems. Okay, so I have a side and I have an angle. I need another side, so I'm not going to use vertical angles, but if we notice, it's kind of the same as this picture. Well, AC is in both triangles. AC is congruent to itself. Reflexive property. You can just put reflexive. So it's this side in the middle. So here's my side, angle, side. So then the prove part is at the end. Triangle ABC is congruent to triangle CDA, and the reason is SAS, or side, angle, side. Okay, most of the proofs that you will do are going to be very similar to this. Okay, so you will see, I'm trying to look at the problems, you will see something's parallel in one of your problems, like given information is parallel. Okay, so let's go over for that. So like writing the given could be one step, making conclusions could be step 2 and step 3, like in your process. And so this is just kind of the third thing that you're going to do. It doesn't necessarily mean write the given down, make conclusions from the given, and then do a vertical angle or a reflexive typically. You should have a side, angle, side at that point. Just what to do with some of the given information. So most of the time when you see parallel, you're going to want to say that alternate interior angles are congruent. So you got to identify which ones are alternate interior angles that work with your problem. So if you see, and you will today, bisect, remember that means cut in half. So the two sides or the two angles that are being cut in that are being cut in half, excuse me, the side or the angle, the parts are congruent. So if you see bisect, you're going to say, okay, this part on the left and this part on the right are congruent. Whether they're angles or sides doesn't matter. Just that's what you want to say. Okay. If you see midpoint, it's kind of the same thing. Midpoint means cut in half. So if something's a midpoint, it can't be an angle. It can only be a side. So then if something's a midpoint, then the part on the left and the part on the right are congruent, and that's what you want to write down. Bisect could be side or an angle. Midpoint is only a side. Okay? So in the given today, one of them you'll have bisect, one of them you'll have parallel, one of them you'll have midpoint, and another one kind of repeats. Okay, and then the kind of the third step in the problem, a huge, and it's not necessarily step number 3 in the proof. It could be, depending on the problem. I think today it will be step 3 on most of them. But there could be 3 steps that come like the third step of the problem. So just kind of make a note of that. But the third step is almost always going to be the reflexive property or vertical angles congruent. Okay, so if you saw, I call it like a bow tie. Here's vertical angles. Just by looking at the picture, you can say those two angles are congruent. Why? Vertical angles are congruent. Okay, so just kind of keep that like in mind. So if you do, okay, so there's 4 proofs. They shouldn't take very long in terms of the steps. Like, let me see if I can just, I think number 15 has 4 steps. I think number 16 has 4 steps. 17 has 5 steps. It could have 4 or 5 depending on how you write it up. And 18 has 3 steps. Okay? But again, try these, please. Don't just like go copy answers down. Okay? These ones are much more doable and much shorter than the ones we did before. Okay? All right. So give it a whirl. Please come back with questions if you have them. That way you can get this, because it really isn't something that's super difficult. All right. Have a great rest of your day, guys. We'll see you tomorrow.